All right, good afternoon, guys. Good morning, guys. This is Trig. Today is June 29th, and our exam is next class on July 3rd, and it's a cumulative exam. These are the sections we will cover: 2.1, 2.2, 2.3, 2.4, and 2.5. And the plan today is to work on 2.5. What is 2.5 about? 2.5 is about tangent function and cotangent function, secant function and cosecant function. So let's jump right into it. Make sure you take the exam on July 3rd. It will be available for 24 hours and you will get about 23, 24 questions. And you will get about 1 hour and 20 minutes to take the whole exam. You want to make sure you have a chunk of 2 hours with you so that you can spend it on the exam. All right, guys, let's dig into it. And my apologies for those of you who were waiting here for me. And I was just talking to myself anyway. So guys, we're going to graph the tangent function and learn a little bit about the properties of the tangent function. So on the, I'll go to Desmos. I'll go to Desmos and I will change this to, let's say, negative 3 pi, and you have to do that. Otherwise, your graph won't work out. 3 pi. You have to make 3 changes, and this step has to be pi over 2. And radian is selected, and it should be radian. Basically, 4 things you have to change if you're using Desmos. All right. Now, so having said that, this is my graph. Okay, it looks a little funny, guys. Okay, we're going to analyze its properties slowly. Okay, it doesn't look like the sine curve or the cosine curve, and I have them here. Just making sure I am recording. I am recording. Okay, so now, so what's going on here is, remember, guys, tan of x is sine over cosine. So look at some of these points, and let's see. Look at this point. Sine and cosine are the same, exactly the same. If you divide it, you should get 1. And look at the tan function. It's exactly 1. It's exactly 1 here. Okay, at this point, this is 1. Okay, this is a problem point. When cosine is 0, what happens when cosine is 0? When you divide sine by cosine and cosine is 0, the division is not acceptable. What happens when the division is not acceptable? It's undefined. That's why you have a break here. The tan function has a break right here. And these breaks are called asymptotes. I'm going to go to the next slide on GeoGebra notes, and I'm going to spell it for you guys. So these are the places where the cosine value is 0. I can see it right here. The cosine value is 0. That's why you have a breaking point. And that's why tangent function looks the way it does. Another important property of the tangent function, guys, is this. I'm going to hide the sine function and cosine function. I don't need it right now. I'm going to talk about the period of the tangent function, okay? Remember, guys, by period, we mean part that you must analyze, the smallest part that you must analyze in order to give me 1 second. There's something going on. Okay, I got it. All right. So take a look at this. If you analyze this bit from 0 through pi, I know I kind of covered pi with the red patch, but it's pi. If you analyze the function in this range, 0 through pi, everything else is a repetition of this. So the period for tan function is pi. The period for cosine and sine function was 2 pi. So this is a little unusual as well. So you need to analyze tangent from 0 through pi, and after that is just a copy of that on the left-hand side and on the right-hand side. So let's take this curve. and take it to my slide where we can write a few things right here. Okay, these properties of tangent function, I'm going to connect it to your graph. I know the graph is a little small. Let me see if I can make it a little bigger. It's a little better, but you have access to Desmos, hopefully. Feel free to do it while you're listening to the lecture. What are they trying to say? The domain. Remember, guys, domain is the input value. On the x-axis, anything is acceptable except for these guys. These are the points where cosine is 0 and the tan function is not defined. And that's all they're trying to say. The domain is the set of all real numbers except odd multiples of pi over 2. The numbers I circled, pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, which I didn't circle, but I could. These are odd multiples of pi over 2. Okay, that's all they're trying to say. The range is the set of all real numbers that are output. Look, the range goes all the way from negative infinity to positive infinity. Anything can be the output here, all these guys. Okay, one way to think about domain and range is pretend you're a tiny ant and you're walking on the curve, any part of the curve. You're walking, and all the possible set of y values are going to be your range, and all the possible set of x values will be your domain. You will never have an x value of this because at this point the curve is broken. What could be your set of what could be the possible set of your y values? Anything. You can go all the way up, all the way down. You can take any y values. If you're a little point on this curve and you're moving up and down, either this one or this one, nobody cares. Your y value is wide open. You can take any y value if you please, but you won't be able to take these x values. That's why your domain is kind of limited and your range is not limited at all. Let's pause here a little bit, see if we have any questions about domain and range. Another good news, you can have this box in front of you, but the best thing is to look at the picture and analyze those points yourself by analyzing your graph. That's the safest thing to do, and that means you understand things a little better. So what do they mean by part 3? The tangent function is an odd function. Remember, guys, when we talked about the sine function, we said, go ahead, guys, if you have any questions. All right. So guys, remember we said odd functions are functions when you rotate them around the origin, them half a circle. Okay, I'm making 2 copies. I'm going to rotate it half a circle and it matches exactly itself. You have to rotate the curve around the center. It's called symmetric with regard to the origin. Tan functions are symmetric with regard to the origin. Okay. So that's number 3. The tangent function is periodic with the period of pi. We explained that on the other slide. Okay. The period is pi, 0 through pi, or just pi. We just say pi because from this point, if you analyze this much, it's a repetition of that. All right. This is interesting, guys. X-intercepts. X-intercepts are the points where the curve cuts the x-axis, and those are these points. And that's all they're trying to say here. Okay. And remember, I said I'll spell asymptotes, and that's how it's spelled, asymptotes. So remember, guys, vertical asymptotes are vertical lines where the curves get closer, to which the curves get closer and closer to without crossing. So these are asymptotes. Where are the vertical asymptotes? At pi over 2, negative pi over 2, 3 pi over 2, right here, another one, negative 3 pi over 2, right here, another one. So this is a summary of the properties of the tan functions that you want to understand. Of course, you'll have the notes in front of you. Of course, you'll have Desmos. Hopefully, you'll be able to graph, but you want to understand some of these basic ideas. I'm going to pause here just a little bit. All right, guys, I'm gonna go and show you the cotangent function, and it's very similar to tangent function. Some of the things change a little bit. So let's see. Remember, guys, cotangent function is simply cosine over sine. And I'm going to put sine in the bottom. That way I can divide things a little better. So y is equal to sine x. All right. So I don't need to show you these, but to me, they're very, very similar. And let's put tangent function back for a second. I don't want, so take a look at the difference between tangent and cotangent. The cotangent function is the red one. That's the one I'm really interested in. The tangent function is the blue one, that's the one we discussed. There are lots of similarities. They both have the same period, 0 through pi. If you analyze the cotangent function 0 through pi, you will be all set. It's a repetition. And their that, let's hide the tangent function for now. It'll just distract us. The x-intercepts are going to be pi over 2, 3 pi over 2, negative pi over 2, okay? Where are the asymptotes? Let's grab this and take it to the, excuse me, take it to our slide where we can write. Where are the asymptotes? So let's bring them here. Now this is for tangent, okay? This is for tangent. The domain is going to be everything except for or even multiples. Look, the domain. I'm going to actually go over it. I don't want to leave it here. It's going to throw you guys off a little bit. So domain, these are the places where the asymptotes are. Okay, pi. Why? Because that pi sign is 0 and you cannot divide by 0. 2 pi, 0, negative pi, negative 2 pi. These are the bad points where the domain is not defined. Range is going to be all real numbers. And what are the x-intercepts? All these points. Okay. Where are the vertical asymptotes? Remember the points where the domain is not defined. You get vertical asymptotes right here. So in structure, the two are similar. How are they similar? They both have vertical asymptotes. They both have their range is everything. All possible values of the y-axis can be acquired by a point on the curve. And there are subtle differences, of course. The differences are in the tangent function, where you have vertical asymptotes, those become the x-intercepts of the cotangent function and vice versa. So again, make sure you play with Desmos a little bit. Desmos is better than your calculator because it's in color, it's bigger, you can copy paste it, and it's also something you can save for later on your computer. So I am a huge fan of Desmos. Try to be comfortable with it. And there's not a whole lot going on with Desmos. It's very manageable. I'm going to give you a couple of minutes to see if you have any questions for me, guys. All right, guys, let's look at the next one. I think it's secant or cosecant. We're going to find out. Very, very similar to what we have been doing. And they will look a little different. Let's do a cosecant one. Let's see which one your book has. Okay, let's do cosecant. Remember, guys, cosecant. Let me see. Okay, I'll go over the things. Let's do cosecant. All right, I'm going to leave it here. Okay, I'll refer to this. This graph is a little nicer, and I'll go over the domain and everything, but I'm going to go to Desmos, and I'll try to graph cosecant x. Remember, guys, cosecant is the reciprocal of sine, and let's get rid of everything. Let's keep sine here. So the blue one is sine, and the and the red one is cosecant. And it makes a lot of sense, guys. Okay. Look, when sine is 1, reciprocal of 1 is 1. When sine is 0 right here, you cannot divide by 0. So you have another vertical asymptote situation. Okay. Take a look at another point here. Let's say sine value here is half and the reciprocal half is 2. You get 2 here. So basically, this is what the graph of the cosecant function looks like. It's nice to have the sine function around so that you can relate to it better. But this is really what we're looking at. Now, the domain, we're gonna do it a little differently. We're gonna type everything up, okay, on the other slide. Actually, I'm better off using this graph. The one in your book is very nice, no question about that. But let's do it from scratch right here. All right. So guys, the domain. What's the domain? The domain is all real numbers, all real numbers, except, I have to change this. The domain is all real numbers, except these. Okay. Which ones? Pi, 0, negative pi, 2 pi, where you have vertical asymptotes. Those are the bad guys. Those points are not defined. So we'll write them nicely. And this is how we're going to write them: 0, comma. And you can write plus minus pi. Nobody can stop you from doing that. Plus minus pi and comma, plus minus 2 pi, and so on. Okay, that's your domain. Okay, what's the range, guys? Range is clever here, okay? The range is, again, guys, remember what's domain and range? Think about yourself being a little point and you're on this curve, up and down. You're going up and down these U-shaped curves. So no matter where you go, you will never reach anything between 1 and -1. There's a little gap here, okay? This place is not available. Why? Because the sine value, the maximum value is 1. Anything less than 1, the reciprocal of that number is more than 1, so they jump up. So there is a lot of gap here. So how do we write that nicely, mathematically? All real numbers greater than or equal to 1, or let's see how we can write it nicely. Range, all real numbers greater than or equal to 1. And I'm going to make another text box. Or larger than or equal to, actually, smaller than or equal to -1. Okay, -1 and +1 are included. And sometimes this is how it's written, guys. What I said here in English, this is also written this way. And you should be familiar with both. Okay. And my computer is gonna not let me do that, but that's okay. I'm gonna take care of it in a nice way. Give me 1 second. Okay. Computers are nice, but sometimes they're not really that nice. All right. So guys, it's important, very important for these two brackets to be square bracket. Okay. It won't let me write one square bracket, one non-square. This has to be square because -1 is included. This has to be square because -1 is included. Okay, make sure you understand that. So this thing that I said in English can also be written like this. This is a square bracket. This is a square bracket. And these are, of course, open parentheses. And this union means all of this is acceptable. All of this is acceptable. Everything between this area and this area is unattainable. Okay, that's the domain and range. I think I have like 10 minutes. I'll be able to finish the rest, guys. The vertical asymptotes are where? I'm going to basically tell you. The vertical asymptotes are here at pi, at 2 pi, at 0, at -pi, at -2 pi. Does it have any x-intercepts? Does the function have x-intercepts? The answer is no. The curve does not cut the x-axis at all. It doesn't have any x-intercepts. Does it have a y-intercept? The answer is no, it does not. This function doesn't intersect the y-axis. This function has no y-intercept. Let's talk a little bit about the period. Now, intuitively, it's the reciprocal. Cosecant is the reciprocal of sine. I'm going to get rid of this, and this too, because this would be incorrect if I remove the square bracket. So going back to the period for sine and cosine is 2 pi, and the period for cosecant and secant is also 2 pi. Take a look. This curve, what you see in the rectangle, is being repeated on the left and on the right. Hence, 2 pi is the period for the cosecant function. Okay, now I'm going to do some problems from your packet. We're not going anywhere, but we do have a little bit of time in this session. I have like 8 minutes. I'm going to show you. I won't discuss it in detail, but just do secant. The secant function is very similar, which is the reciprocal of cosine. It's very similar to cosecant. Okay, there's some subtle differences. The period is 2 pi. Now the asymptotes are in different places. Okay, the asymptotes for the secant function is at pi over 2, 3 pi over 2. Do you have to memorize all this? No. Do you have access to the graph? Yes. Once you do, once you know how to read it, you're in good shape. That's all from this section. So what I'm going to do, guys, let's get out of this session. I'm going to quickly come back and see what kind of problems we have from 2.5. Okay, I'm not going anywhere. I'm jumping out of this session. I'm coming back. Hopefully things will go smoothly. See you soon.